Let's look into today's Leetcode problem, which is rotating the box. So you are given with the 2D matrix, and each of the cell present in the matrix will have one of these values, which is hash, star, or dot. Hash being stone, star being stationary obstacle, and dot being nothing. You can think of it as empty air. So 2D matrix, aka box, is rotated 90-degree towards the clockwise direction, and after rotating it the box will look like this. Basically the dimensions are rotated now, and something happens inside the box because of gravitational pull. So if there is air present in between the rocks, then the rocks will tend to come down, replacing the air. The air will go up. So after all the activity going on inside the box, after doing the rotation and gravitational pull, rocks being rotated, we want to return the resultant array. One thing that you should keep in mind is there is no act of inertia here. Uh, uh, let's take this one as an example. So once you rotate it towards the right, you might think that this rock will move towards the right as well, but that's not happening here. The only factor that we will be considering is gravitational pull. So let's quickly jump into an example here. So I have pasted one of the inputs from Leetcode for better understanding, and we will jump into the implementation part because the question is straightforward. The gravitational pull logic might be a little trickier, but it is quite simple, trust me. So what you should be doing is create a new 2D matrix. Let's say if the initial dimensions are m cross n, then we want the new matrix to have this dimension, and the stones are being represented as hash. So okay, after forming this new matrix, you would want to uh, populate this matrix. So the population happens this way. So the first row will be filled with the last column, and the second row will be filled with the last second column, which is basically the first row. Sorry, yeah, first column. Okay, so it will look something like this. So we have a stone here, we don't have anything, and for obstacle we represent it by star. So first row is done, and for the second row it will look like this, and this is how our matrix will look like. But on gravitational pull it will look like this: hash, hash, star. Pardon me for drawing extra. Okay, I think it's fine, we'll simply ignore this. And here we have air in between the obstacle and stone. So stone should come here, and air will go up. We have an obstacle here. And one thing that you should keep in mind is obstacles are stationary. They are not affected by gravitational pull. So let's make it clean actually. So this is the resultant matrix that we would want to return. Okay. So the first logic should be clear by now. That is, we will be traversing row wise and uh, fill in the gaps here. That is, fill the columns. Now comes the second part, which is the gravitational pull part. For this, I've written some pre-computational code, though it is not related, but we can consider one example before moving towards the actual code. So let's say we have a 1D matrix with us right now, and we have few positions filled with stones and few positions filled with empty air. So what we want to do is move these stones towards the extreme right and move the air towards the extreme left. So one approach that someone could think of is count sort, which is basically counting the total number of stones or empty air present. Let's say we want to count the total number of empty cells, that is the dots. Then it will be 2. So what we do is we iterate the array again, and for the first two positions we will be putting dots, and for the remaining positions we'll be putting hash. This is how counting sort also basically works. But someone can argue that we are iterating the array twice, once to count the total number of dots, and the second one is to do the replacement. So a better approach that should be coming into your mind is two-pointer approach, and I have written the code for that. So, oops. So let's look into the same example again and apply this algorithm. So one thing that you should keep in mind is if you are seeing hash and dot present here, then you want the dot to be on extreme left, which is basically you would want to swap the hash and dots whenever you look into it, and the dot should be coming in the righter direction for the swap, and the hash should be on the left direction. So let's begin with slow and fast pointer pointing at the same direction. And here we are seeing fast pointer is not in the cell which has dot, so this condition is ignored. And slow pointer is also not pointing towards dot, so this condition is also ignored. Actually, in this while loop, we should have fast plus plus. So fast pointer moves one step ahead, and the same thing happens here as well. So fast pointer moves one more step ahead. Now comes the this condition that we would want to happen. So slow pointer is pointing towards the stone, and fast pointer is pointing towards the empty air. So we would want to replace the positions now, replace the values basically. So now the slow pointer will be having empty air, and fast pointer will be having stone. Now this condition also satisfies slow pointer has a dot, so we will move it one step forward, and after the this complete iteration, fast pointer will also move one step forward. Now same condition applies here as well. We will do the swap, so slow and fast pointer will have a swap here. We will move the slow pointer one step ahead and fast pointer one step ahead, and we don't have this condition satisfied, so we move the fast pointer again and we come out of loop. So at the end of day, we can see that we have achieved something that we wanted to do. So we will apply the same logic here as well. The only difference is that we are applying it on a 2D matrix, but the approach is still 1D. So, and the additional cases we would want to have a search space as well. So, we will be doing these algorithms on the search space which doesn't have the obstacle. Let's say we have few more cells present here. So, this will be one search space and this will be one search space. Similarly, this will be one search space and this will be one search space. And that's pretty much it. So I know it would take time to do all the explanations and code as well. So I have already written the code. So this step is basically okay. This step is basically to create an inverted n cross m matrix. We can have anything as a default value here because anyways it is going to get replaced. Now comes the second step. Um, so we will be populating the array in such a way that 2D array, 2D matrix in such a way that all of the first row values will be populated in the last column, and in the similar fashion things go on. And in this for loop we can see the exact same condition that I have written here. The only extra thing that I have added is the ignoring the obstacle part. Whenever you find an obstacle, you ignore it, and you form a new search space. So whenever you find an obstacle, this search space is done, then you start again with this search space, or this search space with slow and fast pointer pointing towards the same cell in the beginning. And that's pretty much it. So yeah, thanks for watching. Bye bye.